Okay, we're still in chapter 9. We're going to be on page 14 here. We're going to ground reference maneuvers. So ground reference maneuvers may be used as training exercise to help develop a division of attention between the flight path and ground references and while controlling the helicopter and watching for other aircraft in the vicinity. Other examples of ground reference maneuvers are flights for photographic or observation purposes such as pipeline or power line checks. Prior to each maneuver, a clearing turn should be accomplished to ensure the area is free of conflicting traffic. Rectangular course. The rectangular course is a training maneuver on which the ground track of a helicopter is equidistant from all sides of the selected rectangular area of the ground. While performing the maneuver, the altitude and airspeed should be held constant. The rectangular course helps develop recognition of a drift toward or away from a line parallel to the intended ground track. This is helpful in recognizing drift toward or from an airport runway during the various legs of the airport traffic pattern and is also useful in observation of photographic flights. Technique for ground reference maneuvers. Maintaining ground track while trying to fly a straight line can be very difficult for new pilots to do. It is important to understand the effects of the wind and how to compensate for this. For this maneuver, pick a square or rectangular field or an area bounded on four sides by section lines or roads with sides approximately a mile in length. The area selected should be well away from other air traffic. Fly by the maneuver approximately 500-800 feet above the ground, which is the altitude usually required for an airport traffic pattern. If the student finds it difficult to maintain a proper ground track at a higher altitude, lower the altitude for a better ground reference until they feel more comfortable and are able to grasp the concept better. Altitude can be varied up to 800 feet as proficiency improves. Fly the helicopter parallel to and at a uniform distance about 1/4 to 1/2 mile from the field boundaries and not directly above the boundaries. For best results, position flight path outside the field boundaries just far enough away that they may easily be observed easily from either pilot's seat or looking out the side of the helicopter. If an attempt is made to fly directly above the edges of the field, there will be no usable reference points to start and complete the turns. In addition, the closer the track of the helicopter is to the field boundaries, the steeper the bank necessary at the turning points. The edges of the selected field should be seen while seated in a normal position and looking out the side of the helicopter during either a left-hand and right-hand course. The distance of the ground track from the edges of the field should be the same regardless of whether the course is flown to the left or right. All turns should be started when the helicopter is abeam the corners of the field boundaries. The bank normally should not exceed 30 to 45 degrees in light winds. Strong winds may require more bank. The pilot should understand that when trying to fly a straight line and maintain specific headings, aircraft heading must be adjusted in order to compensate for the winds and stay on the proper ground track. Also, keep in mind that a constant scan of flight instrumental and outside references aid in maintaining proper ground track. Although the rectangular course may be entered away from any direction, this discussion assumes entry on a downwind heading. While approaching the field boundary on the downwind leg, begin planning for an upcoming turn. Since there is a tailwind on the downwind leg, the helicopter's ground speed is increased. During the turn, the wind causes the helicopter to drift away from the field. To counteract this effect, the roll-in should be made at a fairly fast rate with a relatively steep bank. This is normally the steepest turn of the maneuver. As the turn progresses, the tailwind component decreases, which decreases the ground speed. Consequently, the bank angle and rate of turn must be reduced gradually to ensure that upon completion of the turn, the crosswind ground track continues to be the same distance from the edge of the field. Upon completion of the turn, the helicopter should be level and crabbed into the wind in order to maintain the proper ground track. Keep in mind that in order to maintain proper ground track, the helicopter may have to be flown almost sideways depending on the amount of wind. The forward cyclic that is applied for airspeed will be in the direction of the intended flight path. For this example, it would be in the direction of the downwind corner of the field. However, since the wind is now pushing the helicopter away from the field, establish a proper drift correction by heading slightly into the wind. Therefore, the turn should be greater than 90-degree change in heading. If the turn has been made properly, the field boundary again appears to be 1/4 to 1/2 mile away. While on the crosswind leg, the wind correction should be adjusted as necessary to maintain a uniform distance from the field boundary. Let's get us some pictures. It's number 1. Number 2. All right. Example of rectangular course. As the next field boundary is being approached, position number 5, plan for the next turn. Since a wind correction angle is being held into the wind and toward the field, the next turn requires a turn of less than 90 degrees. Since there is now a headwind, the ground speed decreases during the turn. The bank initially must be medium and progressively decrease the turn as the turn proceeds. To complete the turn, time the rollout so that the helicopter becomes level at a point aligned with the corner of the field, just as the longitudinal axis of the helicopter again becomes parallel to the field boundary, position number 6. The distance from the field boundary should be the same as on the other sides of the field. Continue to elevate each turn and determine the steepness or shallowness based on the winds. It is also important to remember that the bank angles are adjusted in the turn. The pilot is subsequently forced to make changes with the flight controls. All right. Common errors. Common errors would be faulty entry technique, poor planning, orientation, and or division of attention, uncoordinated flight control application, improper correction for wind drift, failure to maintain selected altitude and airspeed, selection of a ground reference with no suitable emergency landing area with gliding distance, not flying a course parallel to the intended area, e.g. traffic pattern or square field. Yes. So S-turns. Another training maneuver to use is the S-turn, which helps correct the wind drift in turns. This maneuver requires turns to the left and to the right. Technique. The pilot can choose to use a road, a fence, or a railroad for a reference line. Regardless of what is used, it should be straight for a considerable distance and should extend as nearly perpendicular to the wind as possible. The object of S-turns is to fly a pattern of 2 half circles of equal sides on opposite sides of the reference line. The maneuver should be performed at a constant altitude between 500 and 800 feet above the terrain. As mentioned previously, if the student pilot is having difficulty time maintaining the proper altitude and airspeed, have him or her attempt the S-turn at a lower altitude, providing better ground reference. The discussion that follows is based on choosing a reference line perpendicular to the wind and starting the maneuver with the helicopter facing downwind. As the helicopter crosses the reference line, immediately establish a bank. This initial bank is the steepest used throughout the maneuver since the helicopter is headed directly downwind and the ground speed is greatest. Gradually reduce the bank as necessary to describe the ground track of the half circle. Time the turn so that as the rollout is completed, the helicopter is crossing the reference line perpendicular to and heading directly upwind, position number 2. Immediately enter a bank in the opposite direction to begin the second half of the S. Position number 3. Since the helicopter is now on an upwind heading, this bank and the one just completed before crossing the reference line is the shallowest in the maneuver. Gradually increase the bank as necessary to describe a ground track that is half circle identical in size to the one previously completed on the other side of the reference line, position number 4. The steepest bank in the turn should be attained just prior to rollout when the helicopter is approaching the reference line nearest the downward heading. Time to turn so that as the rollout is complete, the helicopter is perpendicular to the reference line and is again heading directly downwind, position number 5. In summary, the angle of bank required at any given point in the maneuver is dependent on the ground speed. The faster the ground speed is, the steeper the bank is. The slower the ground speed, the shallower the bank. To express it another way, the more nearly the helicopter is to a downwind heading, the steeper the bank. The more nearly it is to an upward heading, the shallower the bank. In addition to varying the angle of bank to correct for drift in order to maintain the proper radius of turn, the helicopter must also be flown with a drift correction angle, a crab, in relation to its ground track. except, of course, when it is on direct upwind or downwind headings or there is no wind. One would normally think of the fore and aft axis of the helicopter as being tangent to the ground track pattern at each point. However, this is not the case. During the turn on the upwind side of the reference line side from which the wind is blowing, the crab the nose of the helicopter toward the outside of the circle. During the turn on the downwind side of the reference line opposite to the direction from which the wind is blowing, crab the nose to the helicopter toward the inside of the circle. In either case, it is obvious that the helicopter is being crabbed into the wind, just as it is when trying to maintain a straight ground track. The amount of crab depends on the wind velocity and how close the helicopter is to the crosswind. The stronger the wind, the greater the crab angle is at any given position for a turn of a given radius. The more nearly the helicopter is to a crosswind position, the greater the crab angle. The maximum crab angle should be at the point of each half circle farthest from the reference lines. A standard radius for the S-turns cannot be specified, since the radius depends on the airspeed of the helicopter, the velocity of the wind, and the initial bake chosen for entry. The only standard in crossing the ground reference line straight and level and having equal radius semicircles on both sides. The only standard is crossing the ground reference line straight and level and having equal radius semicircles on both sides. Common errors. Using anti-torque pedal pressures to assist turns, slipping or skidding in the turn, an unsymmetrical ground track doing S-turns across a road, and proper correction for wind drift, failure to maintain selected altitude or airspeed, excessive bank angles. Turns around a point. Well, we'll probably hold off there. That's page 16. Page 16, that was S-turns, and now we're going to go to page 16's turns around a point. All right, see you later.